Hello, Andrew here. Welcome to Lecture 2 of the Designing Digital Content in Youthwork module. This lecture will focus on terminology and file formats, so we're just going to do a rundown of different sort of descriptions, mostly around still images and graphics, video format, and audio. What we find is there's an enormous sort of crossover between those as multimedia formats, mostly all converging on web-based technologies. And we'll see that by the time we arrive at the end of the lecture. I'm just going to touch on web, really. I'm not going to go too in-depth into that right now. A lot of these things you will all be familiar with in different sort of guises or ways of, as simple of not being able to play a movie file of something you wanted to watch, or an audio file probably not loading onto a device like a phone, or not playing back through some sort of stereo system. Likewise with being unable to open an image file in an email or something like that. So there are things we've all experienced many times, and there's a number of reasons for that. What I would say about all that is a lot of the as the technology becomes more robust, there's less kind of room for error like that. So we don't find that these problems to be as significant as they would have been before. But I'm just going to point out a lot of sort of the basics of this, really, and just to see where that brings us in terms of an understanding of working with these. It's as good a foundation to put on it, really, when we're moving forward with actually creating and designing content for digital content in the next lectures. So I'm just going to start with the really sort of basic stuff of the difference between hardware and software, I suppose, which a lot of people it's quite explanatory there, of just different things. Hardware being the physical devices that are required to store and execute software, essentially. And software being, the collection of instructions that enables a user to interact with the computer. So that can be mostly in the form of apps, I suppose, different types of application software. System software, programming software, all different things like that. And in terms of the hardware, then it'd be like input storage devices, processing and control and output devices. So anything from scanners to printers to USB keys, mice, hard drives, everything like that. So that's just kind of underline what that is in terms of the differences between hardware and software. In terms of the operating system, then, we're looking at an operating system is system software. It's installed on the hardware that manages computer hardware and software resources and provides common services for computer programs. All computer programs, excluding firmware, require an operating system to function. So, everyone's got the idea of a software installer, a system reboot, and these sorts of concerns that we'd have when a computer kind of crashes or breaks down. Most common and popular sort of operating systems would be PC, Mac OS, and Linux, I suppose, would be the three most popular at the moment that a lot of people would be using. For the purposes of all these lectures, I'm assuming most people are using Mac or PC. But as I said in the last lecture, a lot of the project-based work we'll be doing will be browser-based in different sort of apps. So, the orientation of that and it should be the same throughout. So there's kind of a real generic model for like a ladder of how information is transferred between a user and a computer. And the application, software application, and the operating system being the two layers in between that allows a user to interact with that and create stuff and to, really harness the power of a computer. Now, what we're going to look at now for a good few slides, actually, most of this lecture will be file formats, and just to kind of understand I just want to get past people being bamboozled with different sort of file formats and what are the differences between them. So I'm just we'll subdivide it into three parts of still image graphic file formats, video file formats, audio file formats. Then we look at other multimedia ones that are being left out of there, I suppose, and then just look at web-based stuff as well, just to kind of give an idea of the root hard code. This essentially underlines all this and allows these different sort of quirks and for files to be actually tools rather than problems, I suppose. So a file format is a standard way that information is encoded for storage in a computer file. It specifies how bits are used to encode information in a digital storage medium. File formats may be either proprietary or free, and may be either unpublished or open. So, well, as I said, with a lot of technologies and file formats, or accessibility to file formats becoming more robust and open, those issues of being unable to open specific kind of files isn't as big of a problem. Where that normally has kind of come from is the proprietary nature of a lot of these file formats, where a certain software company or a hardware basically where it relates to a product, and it needing to be proprietary software to run a certain product. And this is where issues have kind of, arrived in the past of being unable to open certain specific or run particular sort of softwares or open files or whatever like that. As I said, most of that's kind of waning now compared to how it used to be, but there is still these sorts of issues of proprietary software and files relating to that being something which is a bit off limits or inaccessible from through other channels, really. So we're just going to break down a few of the terms around image file formats, just so we can get familiar. Again, things we're all very, very familiar with here. So I'm not going to labor on anything too much, really. I just want to kind of breeze through it, and then hopefully you'll use this lecture as a frame of reference if you need a refresher of it, or even if it just confirms things you already know, so be it. So some of the if we look at the images below here, you can see the issue straight away of just a poor resolution in an image. In terms of when we're creating now in the next lectures, posters and stuff like that, this is things that we all need to be aware of in terms of just being able to create a better quality graphic, an image-based poster, or whatever sort of graphic responses we want to make, or with these tools. So this is just going to give us a grounding in that to really find out how to kind of avoid these pitfalls, or poor sort of of things having a poor quality to them. So we look at the resolution here. The 72 dpi images, normally it used to be what was associated with web-based files, where it was just the bigger the file, essentially, the more data it contains and the more processing power it requires, and all that being something slower or less optimized when you're in a web-based environment. Again, with faster speeds of broadbands and stuff like this, and different high-powered networks, that's not as big of an issue as it used to be. But the issue kind of, it's the same issue that applies across the board with all these with all these sort of file formats and different levels of, that you can produce them to. The bottom line of it being, you're trying to optimize something where you don't want some large, unwieldy file format which takes forever to email or to print out or whatever like that. And if you have something too small, well, then the quality of it is poorer, and that's sort of something to be considered. So all that really, and also the different ends of it, the different uses you might want to get out of a file being the other thing. So those three aspects combined, this is what we see is it's more of a situation of deciding what you want to do and how you need to produce this image. And there's no point in having a really high res 300 dpi, which is dots per image, which will be the resolution of that, as opposed to 72 dpi image, which is something much more low res. So if you're looking for like a high quality A3 or A2 size poster, you definitely need a bigger resolution than you would need if you just need an image the size of a postage stamp to appear in like a blog on a website, say. So that's just one issue around resolution, really, that we'll see. We'll see when we look at web later on as well, how that issue is being addressed in terms of 72 dpi images. Two other things we need to comment on here is the difference between a raster image or a pixel-based image and a vector graphic, or an image as well. These issues are most commonly known, I suppose, between the two Adobe packages like Adobe Photoshop and Illustrator, where Illustrator would be more, say, for originating text or graphics. So it would rely on vectors, which are scalable and never kind of break down in terms of their quality, as we see here with the vector image, where it's a series of vector shapes rather than an image-based, pixel-based image like the raster one here. So it's infinitely scalable, essentially, or close to that. So a lot of, in graphic design sense, for a lot of typography, or for building large text-based billboards or anything with like massive text, it would all be built in vectors in Illustrator, which allows it to scale to that size and also allows it to be reduced down to something pretty small as well. So vectors are quite versatile in that respect, but they obviously work better with graphics and for different sort of apply to CAD or engineering ends of it, things that don't need the sort of a detail that you'd need of a photo or an image like that. So, or like a high raw camera image, vectors are no good for that. So the pixel based raster images would cover that. Obviously, as we've seen in the last slide, the more resolution you put in that, the greater the quality of the image as well. So, this is why pixel-based images or raster images can become really, really large in size, the more detail and the more of a resolution that you put within them. So this is one issue we need to just be aware of, the difference between, a pixel and a vector as such when it comes to image content and image generating. Two other elements to talk about. Again, I'm not going to go into a lot of detail on either right now because we can talk, when it comes to the compression, we're talking about basically the data bit rate of that file, and something you're just again trying to optimize it where you'd want to have something which is something where it's not going to take up too much. You're just reducing the cost or the amount of space it needs for storage or transmission. So essentially what it is there's algorithms to take advantage of visual perception and the properties of the image data. They alter them to provide superior results with generic compression methods. So essentially you're trying to trick the eye, where you're finding this in-between level of the fall off in the quality of the image not being too bad. As we look at the 1% one here, we see it's quite terrible. The 10% reduction is still, it's noticeable if you look closer at it, I suppose, and especially when there's blocks of color, you can see it broken up. Where even if we look at the 90% one, so there's a 10% drop in the fidelity, but if we look at the image size going from something which is 725 kilobytes in size to 250, then there's a significant drop off in the size or the amount of data stored required to do that. So again, in terms of optimizing it, compression is something which you really need to. It takes a lot of practice and to get it right, where you can start understanding images and how they work. When I say a lot of practice, it takes a lot of practice to be an expert at it. In terms of just knowing that you can compress something and make it smaller without reducing the quality of the image is all we really need to know right now. If we look at I just put in this other slide about layers. Mostly it was just pointing to image size, and it being something which would drive up the size of an image if you essentially have 4 images laid on top of each other. What a layer is mostly known from Photoshop layers. It's just, they're like sheets of acetate, or like with images with the back cut out of the background stacked on top of each other, where you can see through the transparent areas and see the layers upon each other, and just build these really elaborate collages essentially. So obviously that would have an effect on file size if you have more images combined like that, or you bring other sort of details into it, and how that's all packaged and contained within a file format is again something which would affect the file format that you can save it as, and then also the size of that image itself. So again, just 2 things there I wanted to comment on. The layers we will be looking at later on in more detail when we actually start looking at graphic packages and different things for building posters and actually getting into the graphic design side of it. So overall, then, if we're going to look at, again, everyone is familiar with these different abbreviations of file formats. I'm not going to get, again, it's just, you know that they exist, and now it's a case of we're just going to have a quick snapshot of what the different ones would do, really, just to see where we come from. So what we're looking at here, there's, you know, I suppose the likes of the AI for Adobe Illustrator, PSD for Photoshop Document. These file formats would be proprietary in nature, as the way I described them earlier, where they are associated with the programs Illustrator and Photoshop. And they do apply, they can be opened in other programs, but essentially you would use an Adobe Illustrator file with Adobe Illustrator and a Photoshop document with Photoshop. The PDF file format, which is a portable document format, again, it used to be just, it was invented by Adobe and was something which was more proprietary and working only with Adobe software. It has since kind of opened up and is used like in as an open standard, and it's maintained by the International Organization of Standardization. And it's a fantastic format, especially for, you know, if you're looking at, say, anyone who uses Microsoft Word. I'm sure everyone's using this, but if you want to incorporate images into Microsoft Word and have something kind of styled and laid out where there's text underneath or next to an image, and you have a border or margins on the side of it, all those things, when you used to have them as a Word document or even an RTF file, a rich text file, would be kind of knocked around the place. So what PDF does is kind of hold it all in place, almost like an image, but it keeps the crispness of the text. And again, they can be, you know, there's room for metadata on that file, so that it can, you know, have a password attached to it where it needs to be logged into. You can give people permissions to go in and edit it again. It can even scan for the type of the typography that's in that file. So they're quite interesting and sophisticated files in a way, and quite durable when it comes to using them in an email sort of or an online sort of capacity like that. So in the more basic one, we're just going to look at, like, we pick off, say, the JPEG, PNG, and GIF. GIF would be graphic interchange format. So GIFs would be one of the oldest formats of all. Simpler images and solid colors are essentially what you would use a GIF for. And if you're printing logos or other graphics with a solid block of coloring, that's the one to go with. They're not really good for, you know, you're not good for high-end photographs or anything like that. Another perk with a GIF, especially in a logo capacity, is that you can use it with a transparent background. So that's something where, you know, PNGs would be the same, where you can just get away from, if we look at the LIT logo just over here, where I have that saved, I think, as a PNG. So it doesn't have any, it looks like there's a white background purely because it's there, but essentially I could swap out the whole background of this and change it to any color. And the LIT with the red logo would all keep that fidelity without any white sort of boxy clip art around it. It just helps to make things look neater and more kind of presentable as such, you know. So, but that said, GIFs are good for that sort of blocky graphic stuff. They're not very good for high-end photographs. JPEG, the Joint Photographic Expert Group file format. After GIF, it's kind of came along and became one of the most popular formats for graphics, in particular with web-based graphics, where it was something that it just became quite standardized, and you could use a lot of color. You know, they're very small in size, which can be useful when it comes to, say, early internet, where you just have, you know, small images and small resolutions of images would be fine. The issue with them is that they're very small, which does also create limitations on that, you know. So if you want something more, you know, a really rich image with a huge resolution and a real depth of color, it's probably not the way to go with that. And PNG, a portable networks graphic, is a newer type of format. It combines the best of both worlds when it comes to being able to print solid colors and other ones with continuous color, like a photograph would as well, you know. They don't really degrade in quality when archived or shared, which is another sort of issue, you know, of transmission of the file can see a drop off in terms of the fidelity and the quality of it. They provide a high quality color and resolution regardless of the complexity or simplicity. So they're quite durable and versatile. And as I said, just that sort of the best of both worlds, really, between GIF and JPEG. Sorry, just one more comment on the GIF, I suppose, is where it's had a kind of a renaissance when it comes to animated GIFs, and this idea that you have a file that can basically pack 6-10 different files, image files on top of each other and create this sort of animated loop, but still kind of be you're able to embed it or like include it in a web browser essentially, as a still image as you would have before. So that's another kind of interesting aspect of that, really. The other ones are kind of more high end. If we look at DXF's SVG, is a scalable vector graphics, so that would be like a more an open source version of the Adobe Illustrator files. Target and TIFF are kind of all leading towards higher end sort of, I suppose, raw files, which would be just kind of really a lot of information to be able to store, really large file sizes, things that would be used in high end sort of graphic design and product design environments where you do need huge images to kind of cover billboards or the sides of airplanes and stuff like this. So that kind of, again, just covered. The files formats that you are aware of, and you might wonder why some don't open in some ways. And I just wanted to kind of touch on that really, so you can see the difference with them. So, say for example, if you know you need something, even you can tell by the image in this one, the PNG, the black and white sort of check, or the kind of grey and white check behind the two flowers, that little pattern would let you know that you can maintain a transparent layer. So again, that'd be much like I was talking about here with the LIT logo, that you can just you can create artwork and graphics that will work in different sort of environments rather than just them having to be stuck to the background like a stamp and just kind of duplicated like that. So yeah, that's pretty much all we want to say about the image file formats there for now. And anyway, again, we get after when we come back to posters, or likewise, we will be troubleshooting issues when it comes to the types of image that we are incorporating into our graphic design work and building posters. I just want to talk next about video file formats. And they're quite similar in some ways to some aspects of the image files, whereas in terms of the scale that you want them to, the size of the scale, and the amount of resolution or fidelity within that being the kind of the vital parts of it. Where they differ is most video is always stored in some compressed form due to the enormous file size that they can arrive at. Again, I'll have links to any number of algorithms you might want to look at in relation to this stuff. But if you look at like 4K or 8K video, it's colossal in terms of the amount of I think it was 5 minutes of. I'm not sure what it's probably even larger than this now, I'd say, but I think it was 5 minutes of 4K video would take up a couple of gigabytes of a hard drive in anyway, so they're quite massive and normally used for high-end production sort of. That's the reason why the compression side of it is so important, to be actually able to store it and to have it in a way that it can be transmitted or transcoded or kind of shared in a more easier and straightforward way. Anyway, the bottom line with a video file is the format is made of two parts, which is the codec and the container. The codec is used to compress and decompress the file, so that's the part that kind of allows it to move, I suppose, easier through different sort of hardware devices, or for it to be shared or transmitted in that way. Where the file is just too large and can cause difficulty when trying to download or play the file. And a container is a collection of files that stores information about the digital file. So a whole set of metadata around it. So that can be anything which is like the time and date and the time code of when something was recorded, through to just being able to store other information, be it a good take or a bad take, say when it comes to high-end video film production around these sorts of using these types of technologies. So here's just to kind of bring it away from that high-end thing for a minute, just to something a bit closer to what we would know on a daily basis. Everyone is familiar with these sort of file formats by now. So just kind of looking at it there, where I just want to do a quick kind of rundown of these really, so we can see what we're looking at. So AVI would have been one of the first developed by Microsoft as part of video in Windows technology. And it's probably one of the oldest video formats. It's universally accepted that as the de facto standard for storing video and audio, due to its simple architecture, really. So again, it's something that kind of came along at the time of the first internet boom, I suppose, when multimedia was, something, when multimedia became something in a web-based technology, and they allowed these sorts of versatile files to be transferred. And that's it. The codecs are most generally DivX codecs, and MJPEG would be the most common codecs that would be associated with AVI files. So I suppose the container of it is like, it looks like an AVI file, a WMV file, an MOV file, or an MPEG-4 file. And then underneath that, the different codecs give it a different sort of, set of properties. So again, much like we spoke of being unable to read or open an image, the problem was probably more noticeable for a lot of people when it comes to being able or unable to play a movie file, or having the right player to do that with. So again, there's any number of open source software or things that can kind of help you find a way around those things in order to play them. But essentially it's in the codecs and the way it's actually the file, the architecture of how the file is built, being the issue of it not being able to be read in some places. I'll talk about FLV, the flash video format, which again was kind of, became really well known, and was kind of the bedrock of a lot of web-based sort of video. Since then, it's been, it's gone off the boil a little bit, mostly because it's not very secure. The proprietary nature of it being like an Adobe platform again, and just requiring many updates, and a lot of it basically having a lot of security issues with especially with the Java applets that it needs and stuff. That combined with HTML video, and how massive a success that has been, has really seen flash video formats being hit by that, and being essentially discontinued now by Adobe and Apple, where it's not being supported in a lot of browsers or different devices. So that's the situation with that. Windows Media, again, Microsoft development. Originally used for web streaming applications, again, like Real Video, against the likes of Real Video, and now kind of caters for more specialized content. The files are they're really small video file sizes, and that's what allows them to kind of, be used so heavily in web environments. And then after a further compression, those file sizes get even smaller again. So that leads to a lot of poor quality video. So again, it's that sort of thing of optimizing it, of how it's used and to what end. In a web base, if it's more information, or where it's not an issue with the fall off in quality being one thing, I suppose. One of the advantages of that being small size is that it's the only video file format that allows users to upload and share videos through an email system, or was the case, until other ones like MPEG-4 and Movie, like especially with Google, Gmail, are beginning to support a lot of these platforms for sharing video online as well. As we will see later on in our lecture, where we do upload stuff, or in the video aspect of this module, where we begin to upload stuff and see what platforms will handle and display different video files. MOV is Apple's QuickTime Movie. Again, something everyone would be familiar with and see quite a lot of. Developed by Apple. Mostly it was originally for Macintosh users, and then often in the web for saving movie and video files. There's since been the Apple player that's been released, that's the QuickTime player, sorry, that can be used on Windows systems as well, which has helped to kind of with the ubiquity of QuickTime. And again, that being a container which is quite versatile and, you know, allows for it can allow for kind of high-end codecs to operate within that as well. It does support like a lot of you know, more professional quality video production as well and stuff like this. And then we have the MPEG-4, which is the Moving Pictures Expert Group 4. So that would be, you know, there's the MPEG-2 and the MPEG-1 as well, and these would be standards that have come along. Again, just with, you know, something more standardized for industry. So MPEG-2 would have been the original format for, well, MPEG-1 then MPEG-2 for DVD, and that's something where if you look at the average movie would be, say, Lord of the Rings, which is 3 hours long, and how do you get that onto a DVD in terms of something which is high-end and cinematic of that, where an uncompressed file of that could be something like 30 gigabytes. So, you know, these sort of codecs came along to just enable a really high-end compression of that sort of of files of that size, and allow them to fit onto DVDs, which are 4.7 gigabytes in size, say. So you can see the significant drop in that, really, you know, just of how they would kind of squash that amount of data into a smaller place like that. Since then, they've really kind of come on. The MPEG-4 format it uses a separate compression for its audio and video tracks. And the video is mostly done on MPEG-4, a H.264 codec. And audio would be AAC, which we'll get to in a minute. But overall, that would allow for like you know, a smaller, more versatile video file to be shared on the web. And yeah, that's kind of MPEG-4 is kind of, it's taken on another life in web-based technologies, I suppose, on the back of that. And you know, its quality next to the size of the files that you get, meaning it's you know, it's a goer online, really. So just another quick note to the codecs, you know, of how they work, where it's, if we look in the middle here, we have the video file. So it's like a two-way thing, essentially, of either encoding to that video file or decoding from that video file. So it's just a way of optimizing you know, the amount of, the size of these files next to the amount of data that can be stored in them, you know. And again, I have a list here for, there's any number of different video codecs. We'll get at that, as I said, later on, where we'll start to understand how you can kind of transcode as well. So sometimes if you have a video file that won't play, you can transcode it to a different format, which will output a different codec, possibly in the same container, and you could play that file instead. So there's all sorts of different ways of working that, and it was more just to understand the certain sort of architectures, because it can be quite sophisticated at the high end as we get to 4K, 8K, stuff like this, and then at the low end when it comes to web, where we can just see all sorts of differing sort of codecs and containers being used across the web when it comes to different video formats. So well, that's pretty much it around, just for like a whistle-stop tour of video file formats as well. Again, we have those links there if you need to check out any more about that. So we just want to talk about audio file formats next, and the main difference between these being lossless and lossy audio. And lossy being the most common type with the likes of MP3, sorry. And this is where essentially they remove bits of the bits, like data bits of the file, to make it smaller. So these would be sort of, it could be things like, you know, perceptible, things that aren't really perceptible, I suppose. So if it's like a quiet part of music or a long stretch, or where there's a lot of kind of sound on top of each other, where they can take some of the bits of information out of that to reduce the file size. It does reduce the quality of it, but that's kind of the trade-off, really, of what you get compared to the size of the file. Now, on the other side, we have lossless audio, which is audio is recorded without any musical data removed. There are two types of these though. There are compressed and uncompressed. So compressed has small changes to that to reduce this to reduce the file size essentially, and it doesn't make it as poor a quality as a lossy file, but the changes are still big enough to make a difference to the data size of that. And uncompressed lossless would be just, for any sort of high-end audio recording or production like that, where you don't want any sort of destruction to the fidelity of that sound or the recording of it. So you would keep that completely uncompressed. And that's the kind of the best standard that you can get that from. So just to name a few of these, if we look at lossy formats, we have MP3, which is easily the most widespread of them. And the fact that it can store metadata as well. So if you look at, say, you can have album art or file information about that. So that's one thing that makes it kind of popular, or, that people can, if it's loading up a sound, that it comes with an image and you have the track length and things like this, for example, that it can all appear in a browser. That's something like that, And essentially a 320 kilobits per second MP3 file would be generally accepted, which is a mid-range one, would be generally accepted to be indistinguishable from CD quality sound. So again, in terms of a consumer use of these technologies, that's a fair enough trade-off, or a good enough standard for something which is quite small and manageable like that. AAC is the advanced audio coding, and this is another lossy format and a relative of MP3. It's newer, supposedly better. It is the native lossy format of iTunes, the iPod, iPad, and it normally goes by the extension of M4A. So you'd be aware of this again, and it not being able to play on specific devices, probably in most cases on Android and stuff that's not, Apple proprietary software like that. And then there's other ones which we'll speak about a little bit later on with web stuff of OGG, and there's WMA, which would be the Windows Media Player format. And again, there's compatibility issues around that, so that's the reason why they wouldn't be as ubiquitous or as known as well. In terms of lossless formats, we have the .wav extension is widely accepted and universal as the lossless uncompressed format, so it's kind of high end like that. And Apple's version of that would be the AIFF. Again, same losslessness, same professional quality sound, with the same sort of level of limitations in terms of file size. They'd be quite heavy file sizes, much like WAV files. And then there's another one, the FLAC file, FLAC, which is unlike the two above. They're generally compressed, usually to about the size of the equivalent WAV file or audio IFF file, with a higher end in terms of the quality of it. Really, it's not compressed that it's starting to ruin the fidelity of the sound essentially. So that's it for audio. We just want to look at a few different things like that. So you can just become aware that there's differences. That's all I'm really pointing at here. So if you see different handles where it's a case of, it's a situation that you don't panic about, it's just something interesting that needs to be worked around. Or likewise, you can go and actually look for some, a converter to convert one file format to another, or transcode one file to another, or compress one file, or whatever way you need to do it. But there are ways around it, and there's kind of toolkits available to do that as well, I suppose, is really the vital part I want to point out there. And then in terms of other multimedia formats, which is more or less everything else that we've left out. Again, just kind of, just to point to that fact that if we look at like a lot of these files with metadata or being able to handle different information, a typical multimedia file format may contain a specific or a wide range of this sort of data. So it can have graphic data, video, animation, MIDI format stuff, or even typographical based stuff. So they have the file formats that have space for different metadata. That's when it can be a bit interesting. If we look at something like MIDI format, MIDI information, where essentially there's not much difference between an audio and an image sound, where you can have there's software, which we'll talk about later on, but there's software that you can use to interpret a sound and give like visual effects for like live video DJing and stuff like this, video jockeying with sound, where you can just you can read the same MIDI pattern from the audio which has been produced to manipulate the image at the same time, and it just makes for kind of a more dynamic use and graphic sort of interaction with images. Yeah, and it's essentially from the same data file, or for digital file. You know, that's really what I want to kind of explain with that. There's a link below there, just different sort of multimedia formats instead. And again, afterwards I will put up different references and resources for you to kind of check out in terms of further access, because it's more you just want an archive and a resource of this stuff rather than to become an expert at it, I suppose, because you'll find out, you know, there's a certain number of these file types that you want to use that relate to the type of work you want to do, and other ones that you'll have no use for whatsoever. It's just to be aware that they are there, and there's differences, and mostly if you encounter a problem, that it's in all likelihood related to something like this. And then last thing I want to really talk about is just the web and, you know, HTML, CSS and JavaScript. And I suppose these two new video tags, which would have come out with HTML5 video and audio tag, which allows for multimedia work in browsers really. So that's been a bit of a game changer in terms of, you know, what would be regarded as standards essentially in as regards to, you know, be it resolutions for images, or for what would be a screen size. So a lot of these things have changed in relation to this, and then mostly how people would, we see here in the list here of all the different dimensions of the different sort of devices, from smartphones up to tablets, up to like large laptops and, you know, desktop full screen computers, and then into TVs as well, you know. So it's kind of, it's wide open in terms of standardization when it comes to that. And likewise with different browsers, be it Chrome, Firefox, Safari, Internet Explorer, and what the sort of the algorithms within those browsers can handle in terms of multimedia. So there's situations where you know, the one video file, to play the one video file and to make sure that it will load in different browsers, you would upload a number of different file formats, and that could be MPEG-4s, OGG files as well. And there's a list. God, the other one's gone out of my head, but there's a few different ones of that you would just upload the different files to the different video files to a server as well, and whatever browser was calling on, whatever it was being played in, would call whichever one of those video files would work there. So in terms of designing for multimedia devices and software like that, it's become quite a complex ground there to get something where there's nothing really standardized as such with it. So that is kind of exciting in a few ways, as in there's more room for open source or, you know, shared devices like that. And then in terms of a design sense, it can be a bit of a difficulty in terms of you're not sure how your work is displaying on different devices like that. Again, I just wanted to kind of comment on all it, just to show how significant, you know, mostly when it comes to, as a knock-on from how people watch and, you know, take in different video media in particular, where it's to be what the trade-off is in terms of watching it on a phone, as opposed to the production standards that it was delivered to in this kind of high-end video file. So there's just issues around these sorts of things, and they're ongoing, and it's again, I just wanted to kind of flag that. Okay, so as I said, I just hope that was more of a reference tool, really, you know, just to fill in a refresher for some of you that would know some things, and then, you know, everyone's aware of some ends of it, and just to kind of be confident of what you already know from your use and interaction with these sorts of file types already. And again, just to be aware that when a problem is encountered, which it always is, that there's workarounds to these things really, and each file type has its own sort of set of components which make it more usable or versatile in one regard than another. And it's a case of just there's certain decisions to be made to be made around that, really, just to see what you need the digital files to do essentially. So that's it. Next one we're going to talk about is just project design, where we're going to look at like how to kind of project manager to start off with that in a youth work setting. I'm just going to give some kind of, a framework of how that might be gone about. And then the other part, as I said, we're going to split them now, so there'll be much shorter lectures than this even. Probably 20 minutes lectures, and then the other one will be a practical as well, where we'll start getting materials together to build a poster, and having that discussion, which is about the different the whatever your poster might want to, what you might want to communicate with that, and then we'll just get that sort of, we'll see how much we can refine that to essentially in the next 2 lectures. Any questions or comments on this in between, please feel free to contact me and I'll come right back to you about that. Okay, thank you. Bye.